Welcome to today's video. This is Blessed Elvis. So in today's lesson, we are going to discuss binomial expansions or binomial theorem. So in today's video specifically, we are going to discuss the Pascal's triangle. How we can use the Pascal's triangle to expand different kinds of expressions with very much big powers. So let's say we have x plus y raised to power 2. So how can we expand this? I am very sure that we are familiar with such kind of an expression or how we can easily expand such. What if now we have, let's say, x plus y raised to power 10? Can we easily expand this? Yeah, we can easily expand this, but it may take us a long time for us to come up with the answer. So in this case, there is a very simple formula which we are going to discuss on how we can expand such kind of an expression. Just getting back a recap, when you have a very simple expression such as this one, we can easily go directly because we know that the terms that are down there are coming twice. So in this case, we are just going to write 2 times of whatever we have, and then we multiply to expand such an expression. So this first term here, we will multiply both of these terms, and then when we are done, we come to the next term here, which will expand both of these terms. So let's do that. So let's multiply x multiplied by the first term here, which is x. It's gonna be equal to what? X squared. Then plus x here multiplied by y, we are going to have xy. Likewise, we come to the next term, that is y. Then y multiplied by x, it's going to be xy. Even if we begin with y, it's very much important to follow the alphabetical order. Then we go to y multiplied by y here, we are going to have y squared. Then let's simplify such an expression. So we have these terms which are the same here, that is xy and xy. So xy added to xy, we are going to have 2xy since they are coming twice. And then we add y squared as the one on the right side. So this is the expanded expression of this one here. Now we are going to discuss the Pascal's triangle. So as the name triangle, it goes with this form. It has the shape of a triangle. So on the peak here, on the top part here, we write 1, and then on the in this side and this side, on the far end of the right side and the far end of the left side, we write 1 values. Okay, let's see how this is. So on top here you write 1, and then you keep on expanding. Here you write 1, then you add 1 plus 1, we are going to have 2, so it's going to be 2 here, and then here you write 1, and then you also write 1, then 1 plus 2 here, we are going to have 3, so 3 is going to be here, and then also 2 plus 1 here, we are going to have 3, and then 1 here. When you are done adding, that's when you add 1 on the far end of the expression. Then you also write 1, then 1 plus 3, we are going to have 4, and then 3 plus 3, we are going to have 6, and then 3 plus 1, we are going to have 4, and then we write 1. You just keep on doing like that. So 1 plus 4 is 5, and then 4 plus 6 is what? It's 10. Same, 6 plus 4, it's going to be what? 10. And then also 4 plus 1, we're going to have 5. Okay, so again we are going to have 1, then 1 plus 5 here, we are going to have 6, and then 5 plus 10, we are going to have 15. Likewise, 10 plus 10, we are going to have what? 20. And then 10 plus 5, we are going to have what? We are going to have 15. Then 5 plus 1, we are going to have what? We are going to have 6, and then we write 1 here. So you just keep on going like that. So in this case then, let's just end from here. However, you can continue going as far as you want. So it will just keep on going this direction and this direction, expanding it in that a manner of a triangle. So in this expression, this one here means it's the first power, this here means it's the second power, this means it's the third power, this means it's the fourth power, this means it's the fifth power rather, and this one means it's the sixth power. So the value that you have here determines the power. So here we have 6, we are going to have power 6. Here we have 5, we are going to have power 5. Here we have 4, we are going to have power 4. Here we have 3, we are going to have 3, power 3. Here we have 2, we are going to have power what? Power 2. And then here we have what? 1. So it means we are going to have power of what? Of 1. Now, how do we use this to expand expressions? Let's take the expression that we had in the first place. So in the first place we had x plus y squared. So this Pascal's triangle can be used to expand this expression in an easy way, unlike multiplying each term like we did. So these terms that we have here, these terms, these represent the coefficients of the variables. So we can come up with a formula in which we can be replacing these values easily so that we can expand whatever kind of expression we have been given. Okay, so let's say now we have, so let's write a formula. So a formula that we are going to be using is this one, where we will have, let's say, n. So n will represent the coefficient. Okay, this will make sense later. And then we are going to have, let's say, a raised to power n minus 0, and then b here power 0. Okay, let me just wrap this. So make sure that you write this Pascal's triangle somewhere, because it's gonna be helpful, or rather we're gonna be using it as we keep on expanding different kinds of expressions. So the formula that I'm talking about is where we have, let's say, n a raised to power n minus 0, and then we have b power 0 plus n a n minus 1, then b power 1 plus n a power n minus 2, and then b squared. So it will just keep on going like that. So what have we noticed here? The first thing we have noticed is that the value of the power of b is increasing. So it came from 0 going to 1 going to 2 here. And then the power of a here is also what? Increasing. So the coefficient that we have here is coming from the not Pythagoras theorem, I don't know why that is on my mind, is where we have the Pascal's triangle. Okay, so now let's try to expand using this concept here. Let's say we have x plus y squared. Now if you go on the second term, it was what? 1 2 1 on the Pascal's triangle. So a is representing this first term here, and then b is representing this second term here. So whenever there is a, we are going to replace with x, and then whenever there is b, we are going to replace with y. So let's do that. So this here, the value of n, is the coefficient that we have here. So in this case then, the values that we are going to have, let's say we are going to have, where there is n, firstly we are going to put 1, so it's going to be 1. And then where there is a, we are going to put x, so it's going to be x. And then where there is power n, we are going to write this power here, so it's going to be power 2. And then minus 0. And then where there is b, we are going to replace with y, so it's going to be y. and then where there is 0 there, it's just going to be 0, and then plus. This time where there is n, we are going to have what? 2, so it's going to be 2, and then x where there is a, and then where there is n, we are going to have power 2 minus 1 this time, and then where there is b here, we are going to replace with y, power 1, and then plus. We come to this one here, where there is n, we are going to write what? 1, so it's going to be 1. Then where there is a, it's x, and then where there is n, it's 2, then minus what? Minus 2, and then where there is b, we are going to write y power what? Power 2. So now that we have replaced in here, let's try to simplify the expression. So in this case, even if we have the coefficient of 1, we always ignore, because n variable has a coefficient of 1. So here we are just going to write what? X, and then 2 minus 0, it's just 2, on the power here, it's just 2, and then whenever you have any value raised to power 0, it's 1. So since we have y power 0, it means we have 1. Then 1 multiplied by x power 2, it's just x power 2. So in this case, then this is going to be ignored, since it's just a 1 there. Okay? Then plus. Then here we have 2x. Now, when we have 2x here, on top there we have 2 minus 1, which is this one. So 2 minus 1 is what? Is 1. So here we can have 1, and then here on y we have power 1, so it's y power 1. Okay, and then plus. Here we have the coefficient of 1. As discussed earlier, 1 can easily be ignored, and then we have x here. Then on power here we have 2 minus 2. So 2 minus 2 is what? Is 0. So we have 0 there, and then here we have y squared. So y squared, it's just going to come out the way it is. So hopefully that you are following. So let me just wrap the top part here so that we can write whatever we have done there. So that's the pattern that is usually formed. Okay, so now let's say in this case then we have x squared. It's just going to come out the way it is, that is x squared. There's nothing to simplify there. Here we have powers of 1, and powers of 1 can easily be ignored, because any variable or value which does not have a power, it means it has the power of 1. Okay, so even if we don't include the power 1, it means that whatever variable or value we are going to write has power of 1. So in this case, we are just going to ignore it. So we're going to have 2xy. Okay, then plus. Now, anything raised to power 0, as discussed earlier, is what? Is 1. So x power 0 is 1. Then 1 multiplied by y squared, what are we going to have? We're going to have y squared. So this is the expanded expression. So if you remember, this is the expression that we got in the first place when we had just expanded each term. So by the use of the formula of the Pascal's triangle, we have also expressed this expression in form of an expanded expression, which of course is this one. So as we can see, we can also use the Pascal's triangle to expand the given expressions. What's important is understanding or knowing the values of the powers. Okay, so let's look at another one. Let's say we have 2x and then minus, let's say we have 3y. Let's say this is raised to power, let's say power 4. So after you have this, let's first write the Pascal's triangle. So by now I'm sure you know you have 1 here, 1 plus 1 is 2, and then we have 1 here, then we have 1, then 1 plus 2 here is going to be what? 3, and then 2 plus 1 here, it's going to be 3, and then we have 1. So we have power 4, so we are going to end on the fourth one. So here we have 1, and then 1 added to 3, we are going to have what? We are going to have 4, and then 3 added to 3, we are going to have what? 6. Okay, it's not 46, it's 6 here, and then 3 added to 1, we are going to have 4, and then we have this. So we can just keep on going like that. So since we are ending on the fourth power, which means we are going to end here. That is 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So make sure that you keep this. Now, if you remember, our simple formula was going like n a power n minus 0 and then b 0. Then these values where there are zeros we keep on increasing. Okay, so let's wrap this part here. So we don't need this anymore because now we know the values or the coefficients of this. So the coefficients, let me just write them on the left side here. We have the coefficients of 1, 4, 6, 4. Okay, let me just write this properly. So we have 4, 6, 4, and 1. So let me just wrap the right side here so that we can have the space. Okay, so in this expression we are going to start replacing. Okay, so where there is n here in the first place, we are going to have what? 1, since it's 1 that's beginning here, so we are going to have 1. Okay, then where there is a, we are going to replace with what? 2x. Okay, so it's going to be 2x, open brackets, 2x. Okay, and then on power here, where there is n, we are going to have the power. The power we have is what? Is 4. So it's going to be 4 minus what? 0. And then where there is b here, we are going to replace with what? Negative 3y. So we are going to replace with negative 3y power what? Power 0. Okay, then plus. We go on the second term here, which is 4. So where there is n here, we are going to replace with 4. And then where there is a, we are going to replace with 2x. So 2x. Okay, where there is n is 4. So this time the value will increase from 0 to what? To 1. Okay, and then where we have b here, we are going to have what? Negative 3y. So it's going to be negative 3y power what? This time the value will increase from 0 to what? To 1. Okay, so I will continue from down here for the sake of, because of the space, I'll just continue from down there. And then we go to the third term, which is 6. So where we have n, we are going to write 6. And then where there is a, we are going to write 2x. So it's going to be 2x. So the value now, we have n, which is 4, and then minus. This time it's going to be increasing from 1 to 2. And then where there is b, we are going to have negative 3y. So it's going to be negative 3y here. So negative 3y. So the power here we had was 1. So this time we are going to have power 2. And then n, we are going to add 4. So in this case we are going to have plus. Where there is n here, we are going to have 4. So it's going to be 4. And then where there is a here, we are going to have what? 2x. So 2x here. Okay, and then where there is power, we know it's 4. Power is always maintained. Then minus. This time we are going to increase from 2 to what? To 3. So it's going to be 3. And then minus 3. So minus 3. So for b, I will just continue from here. So make sure that you are writing this so that you follow up. Then where there is b, we are going to have negative 3y. This time the power will increase from power 2 to power 3. Okay, and then let's go now to the last term here, which is 1. So where there is n, I will have 1. And then where there is a, I will have 2x. And then where there is power, we have 4 minus. This time it was 3, so it's going to be minus 4. And then where there is b, we are going to have negative 3y. Okay, and then power will increase from power 3 to power 4. So this is now the end. So it has ended from here since we started from 1. So in this case, let me just create some space so that we can have where to write from. So let me just wrap this since we don't need it anymore now. We have expressed all these values in the expression we have down there. So let's now start simplifying the expression. So here we have coefficient of 1, and coefficient of 1 can easily be ignored. So we have coefficient of 1, and then we have 2x here. So here we have power 4 minus 1. So power 4 minus 1, or rather 0 here. So power 4 minus 0 is going to be 4. So we're going to have 2x power 4. Since 4 minus 0, it's just 4. So it's going to be power 4. And then here we have negative 3y power 0. And we have discussed that anything raised to power 0 is 1. So where there is all of these term, which is negative 3y, raised to power 0, that's going to be 1. And 1 multiplied by 2x power 4, it's just 2x power 4. So you are just going to write that. Then plus, we move to the next one. So on the next one, we have fourth term here, so we are going to have 4. And then open brackets, we have 2x. Okay, and then 4 minus 1 on the power there we have, it's going to remain as 3, since 4 minus 1 is 3. And then here we have power of 1. So power of 1, it means that we are just going to have negative 3y. Okay, then let's move to the next term. So the next term we have is this term here. So let me just wrap the top part here for the sake of space. So we are going to have this. We have dealt with this already. Okay. So let me just wrap properly. Okay, so we are going to have plus. Here we have coefficient of 6. So we are going to write 6. And then open brackets we have 2x. And then on top here we have 4 minus 2. 4 minus 2 is 2. So here we are going to have 2 on the power, and then here we have negative 3y raised to power 2. So it's going to be negative 3y raised to power 2. Okay, and then plus, we move to the other term that we have, which is this one. So here we have the other term which has 4 here, and then open brackets we have 2x. So this time we are going to have, okay, let me just write that properly. Okay, so we are going to have, so the power here on the fourth term is where we have 4 minus 3, and we know 4 minus 3 is just 1, so we are going to have the power of 1. And then for b we have negative 3y raised to power 3, so we are going to have negative 3. Okay, let me just continue from down there. So let me just wrap all of this so that I continue from down. Okay, hopefully you are taking note. It will be wise that you take note of this. Okay, let me just okay, I won't wrap this. I will wrap it some other time. So here we are going to have plus. So we have 4 term and then 2x here raised to power raised to power. So here raised to power 1. Okay, and then where there is for b we had this, so it's going to be negative 3y raised to power 3. Okay, then plus the last one is where we have 2x raised to power 4 minus 4. Now 4 minus 4 is 0. Then 0, okay, let me just write it. We have 2x, and then here we're going to have power 0, and then on b here we had this, which is negative 3y raised to power 4. So let me now wrap this, since it's not necessary this time. Okay, so we are going to have these values, and then also this power is not properly written. Okay, so we are going to have power 4. So this is the expression that we are going to come up with. Now this, even if you don't expand much further, you can simply rewrite it the way it is. So we're going to have 2x raised to power 4. Okay, now here we have negative 3y. So negative 3y, we can easily multiply it with 4. So we are going to have what? Negative 3y multiplied by 4, we're going to have negative 12. So it's going to be positive here multiplied by negative. So since this 3y has negative, we are going to multiply negative multiplied by positive, it's going to be negative. So it's going to be negative. Then 4 multiplied by 3y, we are going to have what? 12y. So here we have 12y, and then we also have this. We also have 2x raised to power 3. Okay, then we move to the next one. So the next one that we have here is 6, and then this one has power of 2. So if you can expand the expression, you can do that, but if you can't, it's better you just leave it like that. So here we have 6 multiplied by negative 3y raised to power 2. Now negative 3y raised to power 2, we are going to have positive 9y squared, because negative 3y multiplied by negative 3y, we are going to have negative 3 multiplied by negative 3 is positive 9. Then y multiplied by y, we are going to have y squared. So this is basically the value that we are going to have there. So wherever there is this expression, we are going to multiply with what? We are going to multiply with 6. So 6 multiplied by 9 is going to be what? 6 multiplied by 9 is 54. So we are going to have 54. So 54 y squared, and then multiplied by what? 2. Even this one you can expand it, but I'm just going to write it that way. You can expand it because 4x raised to power 2, it's 4x squared. 4x squared multiplied by this term here, and then whatever you have, you can write the whole term here. Okay, then plus, here we are going to come on this term here. So here we have negative 3y raised to power 3, and then we have 4 here. So if you want, you can multiply 4 multiplied by negative 3y raised to power 3, or you can just write it the way it is, that is 4, and then we have negative 3y raised to power 3 multiplied by this term, that is 2x. However, if you want, we can multiply 2x. Since it has power 1, it means we just have 2x there. So 2x multiplied by 4, we are going to have 8x. So we are going to have 8x. So plus 8x, and then multiplied by this term we have here, that is negative 3y raised to power 3. Okay, then plus, on the last side here, we have 2x power 0. So anything raised to power 0 is 1. Then 1 multiplied by this, it's going to be this term here. So we are going to have negative 3y raised to power 4. So this is the expanded expression. So like I have said, you can expand if you want further. But even if you just write them with such powers, for example, this raised to power 4 like that, you can just write it like that, unless otherwise you have been asked to expand much further. Okay? So even this way, it's just much okay. So what have we noticed here? The first thing we have noticed is that the values of b keeps on increasing, whilst the values of a keeps on decreasing. From this formula we had na power n minus 0 and then p power 0. The values of these keeps on increasing, whilst the values of a keeps on decreasing. So we are going to have a n minus 0 and then p power 0. If we add another term here, we are going to have n minus 1 and then b power 1. Just like that, the values will keep on decreasing for a and will keep on increasing for b. So make sure that you understand this formula that we use whenever you come to express the values or to expand the values using the Pascal's triangle. The value of n here means the coefficients that you have on the Pascal's triangle. Then the value of n on power here means the power that you have on the given expression. So we are going to discuss in the next video of the same binomial expansion part 2 how we can expand different kinds of expressions with very large powers. You cannot use a Pascal's triangle, let's say, to express this term here. Let's say raised to power 20. Yeah, you can do that, but it's going to take you very, very long time for you to reach where 20 is. For you, as you are expanding the Pascal's triangle, for you to reach where the 20th term is, it's going to take you very long. However, we are going to discuss a very simple method we can use for us to expand such kind of expressions in the next video. So make sure that you subscribe to the channel and also share and like the video so that you are updated whenever I upload a new video such as this one.